Okay, so part 4 of the Unit 9 pre-calc test. Hopefully this is it. But let's take a look. We've got a system of equations with x, y, and z, and we're being instructed to use systems using matrices, which is implying use Cramer's rule. And here is Cramer's rule that we used for the two variables. So z would be dz over d. But this is all going to apply to this problem. Unnecessary to have dz for this one because it doesn't have a z. Anyways, notice I've highlighted the constants yellow. So notice matrix D is all the coefficients of x, y, and z right here. This is not used at all. That's what D is. So we've got a 3 by 3 matrix, and then to find dx, we're simply going to take our constants, replace our x column with these constants. You can see I've highlighted it. And the y column stays the same, z column stays the same. And then to find dy, we just take the y column, replace it with the constants. That's what I've done. To find dz, we take the z column and replace it with the constants, and that's what I've done. Now, just so you know, on future tests, not necessarily pre-calc, but like SAT, ACT, they might just ask you for what's the determinant of, what's dy's determinant, or what's dz's determinant, or what's dx's determinant, or what's d's determinant. But this is saying find x, find y, find z. Now, because we're limited on time, and this is just my approach, I would find one of these three using these determinants and these formulas, and then turn it into a systems of equations. Now, if that's confusing, just watch. I'm going to pick x to find first just because it comes first. So I'm going to find the determinant of x, this one, find the determinant of d, whoopsie, this one, and that will help me find x. So let's just get to work because this is quite a bit of work. So to find d, I'm going to take out the upper left, and I'm not going to literally draw lines, but line there, 1, 3, 2, -2. Remember, it goes plus, minus, plus. So there's my plus. It's there, but it's not there. Minus. I'm taking that -2 out. And then I make a line, -2, 3, 5, -2. Then it goes plus 1. Make a line, so -2, 1, 5, 2. And now I've got some 2 by 2's. So this is -2 minus 6, which is -8 times 3, which is -24. These two minuses turn into a plus. This is 4 minus 15, which is -11 times 2, which is -22. And over here I get -4 minus 5, which is -9 times 1, which is -9. So this is -46 minus 9, which is -54. So that's what d equals. Remember, x equals dx over d. So now we know what d is. It's -54. So now we have to find dx. So hopefully I can fit this on the screen. I'm going to take out, remember this is plus, minus, that's a plus, minus, plus. Take the -4 out. Now we're finding dx. So I take the -4 out. Make the line, 1, 3, 2, -2. Next one has to be minus, which it is, but then I take the -2 out. So again, it's a double negative. Line, so 23, -9, -2. Plus, take the 1 out. Make a line, 21, -9, 2. This is -2 minus 6, which is -8 times -4 is +32. this is negative 40 minus a negative 27, which means plus, so that's negative 13 times positive 2 is negative 26. This is 40 minus a negative 9, which is 49, times 1, which is 49. So this right here is 6. 6 plus 49 is 54. Boy, does that ever work out nice. So 54 is what dx equals. So you can see that x ends up equaling negative 1. Now we could go through the same process, find dy, find dz, but that's a lot of work. We're going to take advantage of the fact that we just found that x is negative 1. We're going to go to the original problem. We know x is negative 1, and so I'm going to pick these top two, just completely random, just because they're top. And I'm going to put negative 1 in here, and that would give me, so 3 times negative 1 is negative 3, minus 2y plus z equals negative 4. Now if I add 3 to both sides, I'm going to get negative 2y plus z equals negative 1. So now I'm going to put negative 1 in here. Well, that's 2. I'm going to bring it over here. So 2 plus y plus 3z equals 20. Subtract 2, subtract 2. So I get y plus 3z equals 18. So here's my system of equations. I'm just going to go ahead and multiply this guy by 2. 2y plus 6z equals 36. I'm going to add this to this because I can see my 2y's are going to cancel. So I end up getting 7z, z plus 6z is 35. That's a warm fuzzy. So z is 5. So now that I know 2 of my 3 things, I can just pick one of them, plug this in and this in, and find y. I'm going to pick the top one. So 3 times negative 1 minus 2y plus z, which is 5, equals negative 4. So this is negative 3 plus 5, which is 2. So negative 2y plus 2 equals negative 4. Subtract 2, negative 2y equals negative 6. So y equals 3. So technically my answer would look like this, because it's a coordinate point where these 3 planes intersect. It's like the corner of a room. And there you have it. Okay, just to speed things up on number 20, I've already got the drawing for you. 2, negative 1 is right here. 8, 9 is here. Negative 5. So like I was saying, this point is negative 5, 5. This is 8, 9. This is 2, negative 1. And we've got a problem asking us to find the area of that triangle. Now I'm not going to bore you to absolute death, but if this is a 90-degree angle, we could find the area, we could find the length of this and the length of this and go 1/2 base times height. Now I'm not going to take the time to do it because I know they want us to review all of our laws of sine, cosine, area of triangle, maybe distance formula. There's a lot going on. But what's a little strategy? I could find the slope of this, find the slope of this, and if they're opposite reciprocals, that proves that these are perpendicular. Then I could use this length and this length. But we got to use the distance formula, which is just the Pythagorean theorem, 3 times between here and here, here and here, here and here. Now I'm not going to waste your time. I'm just going to figure the distance here, show you how to do it, and then do it while I hit pause and just show you what the answers are, just to save a little video recording time. So let's just find the distance between here and here. So this is x1, y1, this is x2, y2. We're just going to plug and chug. x2 is 2, x1 is negative 5 squared plus y2 is negative 1, y1 is 5 squared. So that's 2 plus 5 is 7, squared is 49. Negative 1 minus 5 is negative 6, squared is 36. So I know that that length is the square root of 85. So that right there is the square root of 85. Now I'm just going to do the same thing between these 2 points and these 2 points. And then actually I'll show you something else. I'm going to go this way from 2 to 8 is 6. And then from -1 to 9 is 10. And you guys might remember the old family 6, 8, 10. But the hypotenuse can't be shorter than the sides, so that wouldn't work. So now I'm going to have to use the Pythagorean theorem. But I'm going to hit pause here. Okay, so you can see that this is pretty messy. But what I did is I showed you guys just use a squared plus b squared equals c squared. Then I broke this down into a decimal. This one, I already did the distance formula between here and here. You can practice it if you want, but that's the square root of 185. My work is right there, and which is 13.6. And this is 9.2. Now I labeled it, this is side C because it's opposite angle C. I just labeled this A, B, C on my own. So this is side C, this is side A because it's opposite A, and this is side B because it's opposite angle B, and that matters with all these formulas. So now we've got 3 sides, no angles. Now what that means is we can't use the law of sine yet. We're going to have to use the law of cosine, and using these crazy decimals. So again, not going to waste all your time. I'm going to plug this information into the law of cosine. Give me a second and then we'll talk. Alright, so as you can see, I've plugged A in there, B in there, C in there, B, C, and we're going to find angle A using this formula. So give me a second. I'm going to hit pause. Alright, so squared that, squared that, squared that, multiplied that all out, and I'm to here. So I'm going to add these together. So 185 plus 84.6, 269.6 minus 250.2 sine of angle A equals 134.6. Now one of the reasons I'm showing this and taking up video time is some students will be tempted to subtract 250.2 from this, but you can't because these aren't like terms. So this is, we got to subtract this from both sides. And now I'm going to hit pause, whittle this down a little bit. Well, yeah. So that takes us to there. So now we got to divide by negative 250.2, divide by negative 2. This was supposed to be negative, almost didn't catch that. This minus this. 250.2. So these two negatives cancel. Pause. Alright guys, sorry for so many interruptions if you're noticing on this recording, but I'm trying to take care of this during class and it's not working out too well, but we're nickel and diming it. So let's just continue from here. And here we go. So I'm going to take 135 and divide that by 250.2, and I'm going to get 0.54. I'm rounding a little bit, equals sine of angle A. Now clearly I'm going to have to go inverse sine 0.54 on my wonderful calculator. So here we go. Second sine 0.54, 32.7. So angle A is 32.7. Now it sure would be nice if that's all they wanted, but I can go to my drawing and go, aha, that's 32.7 degrees. Now here's the good news. To find the area, I've got 3 formulas. Now notice, I found angle A, so that means I'm going to use this formula to find the area. And I never had to use the law of sine, so we're going to plug things in where they belong. 1/2 B, which is 13.6, times C, where is it? 9.2, times sine of 32.7 degrees. So I'm going to crank this out on the old calculator and be done with it. So sine, whoa, you better check mode. I borrowed a calculator. We're in degrees. All right. Sine of 32.7 And then I'm just going to go times 0.5, get that 1/2 out of the way. And then times 13.6 times 9.2. And I get approximately 33.8 square units. Let me hit pause. All right, going to try to squeeze in number 20, and this is the grand finale, I think, except for that one problem with the tides. But it's, oh, I'm sorry, number 21. It says, calculate the area of a parallelogram. Haven't dealt much with those. Defined by the vectors. Now, just so you remember, these little pointy guys aren't parentheses. They mean component vectors. That means they originate from the origin. And those are the endpoints. So we've got 7, -1 here. We've got -6, -10 here from those points, those given points. But there's a bonus, and we're going to need this perhaps, but that's 0, 0. Now what's this business about calculate the area of a parallelogram? I don't see a parallelogram defined by these vectors. Well, here's the thing. The little twist on this problem is this is 7 to the right, 1 down, has to have the same slope. So if I went 7 to the right of this, I would be to 1, and then I'd be down 1, which is right there. And by some little logic, 7 to the right, 1 down of that would be 1, -11. And now look what we have. Now my drawing's not perfect. I don't know if this is even going to end up looking like a parallelogram, but I think you get the point. And then this goes right here. So we've created our parallelogram. Now, I know that back in the days of geometry, a parallelogram that you're used to kind of looks like this. This is my base, this is my height. I don't think we have that luxury. And I think that's going to cause some problems if we're locked in here to go base times height, because we'd have to find this length, and that might be a lot of extra work we don't need to do. So let's try to connect this to what we've been talking about this whole trimester or year. If I cut this thing in half, now I've got a situation very similar to the previous problem where I have 3 corner points, and we took care of it by using the law of cosine. We found an angle, and after we found the angle, we could find the area. And we're going to tap into that sort of logic, but I'm going to save some time and just tell you that I'm going to use these 3 points here. I could use these 3 points, but I like the fact that there's some zeros involved because that's going to eliminate some unnecessary work. So my game plan is find the area of this and then double it. So I'm gonna take some time, a second here, and I'm going to use distance formula or Pythagorean theorem to find that. I'm going to use the distance formula to find this, and then I'm going to use Pythagorean theorem by going left 6, down 10, and then to figure that side out. So give me a second and I'll show you my work in a minute. Alright, so here's my work. I just used 7 squared plus 1 squared, or -1 squared, equals c squared right here, Pythagorean theorem. I got the square root of 50, which comes out to 7.1. Over here I did the same thing. A squared plus b squared equals c squared. I found c to be the square root of 136, which is 11.7. Boom. And then I just used the distance formula. x2, y2, x1, y1. This is y2 minus y1, this is x2 minus x1, blah, blah, blah. Whittle it down, 15.8. Now, I don't have any letters, so in this triangle, I'm going to call that A, call that B, call that C. So I know this is side A, I know this is side B, and this is side C. And so what we're going to do is we're going to use the law of cosine in this crazy triangle, and I'm just going to go ahead and find angle A first using the law of cosine, but I'll be right back. Alright, a couple of big announcements. Number one, after using the law of cosine, all of a sudden I remembered the previous problem. You guys are already probably remembering this. Notice I used the law of cosine, but I accidentally put sine in there. Now I corrected it up here, so I now know that I screwed this problem up. We'll fix this in a bit, but make sure to listen to the, look at the description of the video. Anyways, let's finish this problem. So, there it is. I've stuffed everything where it belongs. A goes here, B goes here, C goes here, same, same, same. Give me a second, we'll figure out what this is. Alright, you can take a little peek there. I'm just whittling things down. I got to here. The reason I stopped here is to give you another warning. You cannot subtract 369.7 from 386.5. Not like terms. Be right back. Alright, so here we are. Took care of this. Divided both sides by 369.7 negative. I rounded it up here just a little bit, so don't panic. And then the cosine of A turns into whatever this is, which is right here. So now I have to go second cosine 0.91. There we go. And let's see what the calculator has to say to us. Second cosine 0.91, 24.5 we'll round it to. So angle A is approximately 24.5. So I'm going to go to my drawing. 24.5. And now I'm locked and loaded, ready to use the law of the area law. I got angle A. Hopefully I don't screw this up. 1/2 BC sine of angle A. And let's plug some stuff in. 1/2. What's B? 15.8. What's C? 11.7 times sine of 24.5. Now figure that out. Alright, so in my hurry to be done with this video, I almost made a major mistake and said, hey, there's your answer. But remember, that's just this. So once we calculated this to be this, we got to remember to multiply it by 2. So the grand finale, 76 point, we'll call it 7. So approximately 76.7 square units is the area of that there parallelogram. That's a lot of work. Alright, that's it. The final video will have the infamous tidal wave cosine, sine, sinusoid business. But stay after it. Nickel and dime, nickel and dime. Ask questions if you're confused. Appreciate your effort, you guys.